My name is Nick, and if you haven't heard of TERC, I wouldn't be surprised. There's really only three things that you may have encountered. The first is if you have a child of the right age, we're responsible for the investigations curriculum, just kind of the new math thing that has a bunch of ancillary services attached to it. The second thing, if you're young enough, you may have played the logical journey of the Zumbinis in school, but I don't think anybody here kind of fits that age group. So you've probably never heard of us, and that's fine. So the second thing I wanted to go into was what exactly do I mean by SDI? And software infrastructure is kind of something that I've kind of started getting into as an outgrowth of performing continuous integration and continuing delivery on my own configuration management stack. And the reason why I started doing that is that when I arrived at TERC about 4 years ago, TERC's been around for about 50 years, and we're a very tech-heavy nonprofit. So we had 5 to 6 racks full of servers of various ages, lots of kind of technical debt and cruft, things that built on other things, solutions that were patched in for problems that ended up creating problems later, and lots of kind of hidden interdependencies there. And of course, it's impossible to just leave everything as is, because we'd basically be spending our entire time babysitting it. Not to mention that there's kind of always outside forces forcing you to change, whether it be regulatory requirements or new service requirements, or NSF changes what they want, and we're primarily an NSF-derived institution. There's always something that forces you to change things. While at the same time, we're too small as an organization, we're only about 120 people, to kind of put in place those formal, big, IBM-esque move-out change processes where you have people doing some of this automation and multiple levels of review, and you put something in, you wait a week, and it comes back. So I started looking at this, and I was trying to change and clean up technical debt, and it was very hard to tease out the dependencies. And coming from software, I started thinking that this looked very familiar to me. This kind of all these disparate services that are linked together with unknown dependencies, and I shove them all together, and if I mess with things the wrong way, it explodes. And what I thought that looked like was an integration problem. So if anyone's not a software engineer, integration problems kind of arise out of the imprecision of human language. So as you work on a large enough system, you get beyond the point where a single person can work on it and contain it all within their head. It starts getting chunked out to teams. Those teams are given specifications and told to write code to the specification. At the end, you put it all together, and hopefully you have a complete product. This never actually works out the way it's supposed to. So things have a tendency, especially in really complex projects, to have horrific integration problems because of unknown dependencies, or people interpreting specs in different ways, or just varying levels of competence. And so with that being said, I'm going to go ahead and blow, Sorry.
That's a nice way of saying that.
Yeah. Okay. Yeah, varying levels of competence, or even language capacity. So to go into an aside for a minute, this is kind of going to drive home a bunch of stuff that's been said, either at this summit in the past or today. Just kind of do a general kind of CICD, state-of-the-art conceptual overview thing here. I'm just going to do a single sentence about each one of these topics. So I'm not going to go into a lot of detail about it, because I think everybody here is probably familiar with it, but just in case you aren't, so you don't get completely lost. Test-driven development is very easy. You do the test first. The tests form part of the specification. Continuous integration, if you think of any given change as working up a certain amount of technical debt, continuous integration is a methodology by which you integrate more frequently in order to diminish the amount of technical debt you incur. So to diminish the size of those integration problems by integrating frequently. Continuous deployment or continuous delivery, CD, is kind of a workflow modification to CI, which basically just says that at any point in the workflow, you could deploy what you have. Separation of concerns, which is another, not just development-related topic, but just a general topic. You want to have a model to separate out your concerns. A good example that everyone here should probably be familiar with, or at least passingly familiar with, is the OSI model. Separates out concerns out into the layers. And I'll go into a couple other models later. Unit testing and functional testing and the difference between them. So a unit test in CM would be my CM product needs to put a config file in this place. Is there a config file in that place? Functional test would be Apache. That's a config file for Apache. Does Apache start? Does it run? Does it respond to requests? Functional testing is kind of analogous to monitoring in a sense, if you're a sysadmin. Acceptance and smoke testing, which is a giant can of worms. Smoke tests are mainly to save QA time. Acceptance testing can be whatever your organization defines it as. And regression testing, which is another giant can of worms, in which you test whatever your final thing is against previous bugs to make sure you haven't reintroduced anything, which again is a giant can of worms because you don't want to test against absolutely every single bug you've ever had because that would create an ever-increasing list of things you have to test against, which eventually would mean your build length goes to infinity. So that being said, here's a basic CI workflow. So developer makes a commit. You have repository pre-commit hooks. The general concept is a lot like Lean, if anyone's familiar with system engineering or manufacturing. You want to fail as early as possible with as little resources spent as possible. Kind of like if you're making a car, if the frame has a defect, you want to detect that and not finish building the car. So they make a commit, you do a pre-commit hook to do basic trivial tasks like make sure it meets stylistic guidelines. You can get kind of fancy with commit hooks here. I was talking earlier about like limiting commits to certain sizes or file amounts. You might not need to go that far. But once the commit takes place, the ideal world, each commit triggers a job on your continuous integration server, which is probably Jenkins. We don't live in an ideal world, and you probably don't have the resources to do this, so it'll probably run at a scheduled or set interval. The actual build, CI server builds it. At this point, speed matters a lot. Build succeed, yes, no. Then you run your unit tests and your functional tests, and feedback is returned. So, and all of this you want to go through, again, as quickly as possible. This doesn't include deployment or delivery, so that's where we get into with CD. So CD is exactly as before, commit, integrate, build, test. Feedback, did it break? Yes, no. With the added thing of gatekeeping and deployment. You saw kind of a gatekeeping deployment role earlier, one of the CF Engine guys' presentations, whose name escapes me at the moment because I'm a little nervous. Joe? Yeah. Joe's presentation had a lot of gatekeeping components to it. One of the key things about gatekeeping is that you never, ever want to QA your own stuff and knows absolutely no one else will do it. So if you're the one making the changes and staging the changes in this kind of workflow, you should never be the one to approve actually releasing those upstream. Now, in the real world, you might be the only person doing it or the only person who knows how to do it, so there might be, you might have to, but a good example of why not to do this is if anyone here use Vagrant? Anyone here use Vagrant in CentOS, EL6? Yeah. I submitted a patch for guest additions to Vagrant and broke Vagrant 1.6 for all EL6 guests because I forgot that the BIOS devname package I was using to detect the network interface was included in base and not core. So core is the default bareline CentOS machine. Base is the normal minimal install machine. So if you're building a VM container, you only install core, you don't install base, and thus the package wasn't there. And because the package wasn't there, networking broke on all machines, and we have Vagrant 1.6.1 now. And I had to apologize to an awful lot of people. Yeah. So I'm sorry. But again, that's a great example of why you don't want to gatekeep yourself, because that's something that had I actually involved other people, they might have caught that I had made that assumption, which was a very bad assumption to make. So the kind of key thing here for SDI anyway is builds. So what do you mean by builds in an infrastructure context? So you kind of break your builds down into two, partial fast and a full build. So a partial build, you need certain things. You're testing delta changes. In order to ideally test delta changes, you need snapshot and rollback capabilities, so we're probably talking some kind of VM environment. Again, because speed is key, and again, because you want it to be as low cost as possible. For a full build, you're probably doing a full machine or service build out, probably from scratch, probably including multiple machines. And that's going to have a really high cost in both dollars and time because you want it to be as accurate as possible. or as accurate as you can afford it to be, would be a better way of putting it. And because of that high cost, you're going to want it to be infrequent. So, and your end result of what this build is, what this deliverable is going to be, may be a dependency for somebody else, depending upon where you work and what you're doing, or maybe the final product. And if you have a development team, then your DevOps or infrastructure or container build system should probably be separate from your application stuff. So you don't want to be bogging down development with your infrastructure CI, because it will bog it down and everyone will be very unhappy. So what we end up with is this kind of basic CI toolbox. This is kind of Puppet-centric, but it really, the key concepts kind of work for just about anything. So you got your configuration management, which I'm just using Puppet here as an example for the stack. Your CI server, which is, in my case, Jenkins, mainly because that's what I'd used. Virtualization or cloud infrastructure, so we are ESXi and AWS, but there's no reason why you couldn't do Hyper-V in Azure, really as long as there's an API to interact with it. Unit testing, we use RSpec Puppet and test unit. Functional testing, we actually repurpose Nagios. So we just use our Nagios tests that are built into the services to test the services, make sure they work. Automated provisioning, so a great example of automated provisioning, even though you can't use this for ESXi, is Vagrant, or you can't use it for ESXi yet. And a version control system, preferably one that supports hooks. So in our case, we use Git. Now there's additional stuff you can tack onto this, like code review and a lot of other things, but this is kind of the basic core stack of stuff you need to do this. And what we end up with after that is a kind of looking at this as a simplified CM concern stack. So what are you actually integrating? What are you testing? What do you care about? So separation of concerns means we want to separate our parameter or configuration data from the application code, the code that applies it. We also want to separate that from the underlying platform. So we end up with kind of a 3 broad category of concerns. And this is just one model. You can use another one. I happen to like this one because I don't know, it makes sense to me. So for our parameters or configuration data, we might have HIRA data, an external node classifier. This is, again, Puppet specific, and I apologize for that. Exported resources. Our application code in Puppet is going to Puppet Forge modules or Puppet modules. In Chef, it will be cookbooks. Infrastructure platform concerns are the underlying infrastructure that runs all this stuff. So your cloud infrastructure, OpenStack, ESXi, physical hardware, networking, everything. And what exactly those infrastructure platform concerns are also comes back to what the deliverable was. And what the deliverable is going to depend highly upon who your audience is. So we have a pretty kind of wide range of audience. We have Docker, which is probably all containerization and cloud and virtualization. And I think we have 1 or 2 more traditional kind of government or educational infrastructures that have servers that probably have names and do lots of things. And the way I kind of think of this division is based on who your audience is. So if you have internal developers, because you're developing products that you sell, your users are external, and you're likely going more towards the DevOps cloud direction. So you're likely looking at things like precompiled catalogs, local provisioning, masterless CM, where you're running your CM once, and then that becomes a deliverable that's developed against, and it's kind of doesn't get changed after that. Or your deliverable may be a server, or it could be that kind of container, or a different kind of container. Whereas if you're talking about external developers, you're running pre-canned solutions, you're not doing the development in-house apart from maybe the CM for it. And most of your users are internal, although you may have outside users of those services as well for collaboration purposes. In that case, you're probably almost certainly at this point in time in a client server or other more dynamic CM model, not a masterless Puppet. And you're worrying about things like code marshaling and or deployment of code, configuration staging, deployment, multi-phase release processes, et cetera. And your endpoint deliverable is almost certainly going to be, if not a server, a collection of servers. So it probably comes down to actual physical stuff. And for that second one, which is the environment I'm in, you run into a problem, which is a high-cost build problem. So full builds require an ever-increasing amount of resources. They can go up to and beyond, like a completely cloned version of your infrastructure, which you will never, ever get management approval to do, no matter how much money it would save. So you're not going to be able to do that. So you need to come up with other strategies to reduce complexity and cost. And here's where it gets really, really variable. So the easiest way to do is dependency resolution. So if we're changing the Apache or Nginx module in Puppet, we don't need to integrate absolutely everything. We just need to integrate things that relate to the Apache or Nginx module. So we probably don't have to worry about DNS, although we might, just an example. So we need to know what systems our application code piece is applied to. And the easiest way to do this in the Puppet world is mcollective polling. You can create a custom fact in mcollective and say, mcollective, give me a list of all servers I have that have this Puppet class applied to it, and it'll come back and go, here. We need to know what systems do parameter changes affect. So this actually gets complicated. We use a custom Hira plugin that works just YAML-based that logs what the ultimate source of configuration parameters were. So, and logs it into a MongoDB database. So what happens is you can actually, you change a config file in Hira, which is just YAML checked into GitHub. And once that change, it uses the file name in the file hierarchy to determine what systems that applies to, based upon what systems that file is applied to in the past, or is that configuration data from it applied to in the past. It's not perfect, but it's better than just kind of certain assumptions. If anyone has a better way of doing this, I would love to know. So please get the wheels turning there. The next thing is exported resource interdependencies. So Puppet allows exported resources. And the easiest way to do that is catalog parsing or a straight Puppet DB query. The problem with dependency resolution is it's very greedy. We're going to get a lot of things we don't necessarily need. So we need some form of deduplication strategy to minimize that. And one of the key things I use is a classification model. So I classify my servers into, I'll get into how exactly I do this in a minute, into certain compartments or broader classes, or a web server is a web server is a web server. Although it might not always be a web server, it might be a different type of web server. And I like to use pools of easily replicated systems or platforms that are broadly useful, but you can add that extra specificity. And to do this, there are two models I've seen that are really, really good. The first is Chris Dunn of Puppet Labs' roles, profiles, components model. The one I used last year was a services, roles, classes, nodes, pools model. It doesn't really model what model you use as long as you have one. I don't think there's been enough data really to determine which way, like a one true model that you should use, or even if anyone would ever really accept that within the community. And the second thing you can use once you have systems classified is Canary servers or builds. Matthew Barr talked about this, I think, for about 15, 20 minutes last year. It's a really good talk. I've got the link, I think, at the end of this. So what I mean by that, if once you're past a certain point, you're too big to be able to say, F it, spin up everything, so you need to deduplicate. And here's an example of a software stack, so what would be a class. So we'll use LAMP because everyone knows LAMP. This is the Wikipedia pull down of LAMP. It has kind of, it's not necessarily the most representative of what we're talking about, but it's the easiest to comprehend. It has natural scaling points to it. It's a single stack. You can run it on multiple servers or one server. It works really well for a Canary classification-based approach. So, as an example of how that actually ended up shaking out at TERC, although I don't know if they're still doing this, you end up with a web stack, web Canary, and then off of the, which includes everything on the right. And then going down the list, you have our Rails applications, because we have a bunch of Rails applications, our PHP applications, because we have a bunch of PHP applications, Cold Fusion applications, because we have a bunch of those, our Tomcat stuff, because we have Atlassian products and a bunch of other Tomcat stuff. Then at Ruby, we have our Puppet masters, and then the general Rails stuff. So, but whenever we make a change to any of those classes, we only spin up one server, which is the web Canary server, and we test all the changes on that. So if you're paying attention, you'll notice that I've been ignoring what the title of the talk is, which is Infrastructure Platform Concerns. So I'm here represented by Professor Honeydew getting ready to plug Beaker into what looks like an L520 mains connection. So if you're not cloud-based, or or if you are cloud-based, you probably don't have to worry about this as much because you don't have to worry about the underlying hardware your stuff runs on. Somebody else is doing that for you. But for those of us that do, it's probably good to look at what the state of things are. So what do we have to manage this stuff? We have pretty good ways to manage actually an awful lot of things. We can do distributed computing workloads really well, whether those are container-based. VM, which I'd argue is a different kind of container that's not as good. Unabstracted, if you can directly queue out a distributed workload to something. We're really good at server provisioning. So we have everything from operating system specific provisioning, like Kickstart or Precede, or tools that build on top of them, like Cobbler or Foreman, or even run once masterless config management. And we're really good at virtual machine provisioning, Fog, RBP Mommy, Vagrant, etc. And programmatically doing changes to things has been a solved problem for a really, really long time. I think I mentioned that Mark Burgess started doing stuff in the early 80s. So, and I know for a fact that you can do pretty much everything you can do today with David's Otter book from 2000. Not that you would necessarily want to do that because what we have now is better, but you could do it. So we're getting better. It's solved, it's not perfectly solved. And we have increasingly good ways of information gathering and analytics. So to do the dependency resolution, you need lots of analytics and data gathering. Even just to ensure idempotence in certain things, you have to ensure that. So what don't we have? We really have absolutely nothing in the freaking network. So the network is a brick wall. You try to do configuration management on the network and it doesn't work. We don't have, although this is changing, I should say, because I made a note there. We don't have an inexhaustible army of robots that we can tell to do things. And again, on the network, because the network is a brick wall, we don't have anything vendor agnostic. And I don't mean vendor agnostic because your environment should be heterogeneous. I mean vendor agnostic because ideally the tool should be. We shouldn't have to worry about whether or not you're running Juniper or Cisco or Avaya or who your switches are. And depending upon your configuration management choice, again, because I know Puppet, that can make certain things very, very difficult. A great example in Puppet is introspection. Good luck doing it. You're not going to. And so what we kind of end up with here is a hierarchy of SDI difficulty. So if you're working mainly in cloud or virtual, it's a solvable problem. You can use your configuration management to build your networks that run your configuration management and make it turtles all the way down. This may not necessarily be the best solution, and it's not exactly easily done, but it's imminently solvable with the tools we have today. To get down to physical servers, depending upon your scale, compromises might have to be made there. So you don't have as much control. You might have to increase standardization. There's not as many options. Once you get onto the network, you start running into problems of getting sufficient certainty to make changes because you don't have the virtualization or workload distribution stuff. And once you get onto the physical layer, like cabling, that's just not going to happen. Again, without that army of robots. So, and again, I should say a lot of these issues vanish or become manageable at scale, particularly physical servers. We start talking about provisioning stuff by the rack or data center and putting shared images on it. It becomes a slightly different problem than if you have 5 racks of servers in a back room and running a bunch of different services on them. So why are those difficult things different or difficult? There's a lot of high vendor variance in nuts and bolts or API calls. So Junos versus iOS versus NOx are all very different. They all have their own APIs if they have an API at all. And they all are managed differently, even from command line or SSH. Now, there are certain things that kind of abstract from this, but not really well. And what this causes, just again, networking, is it's difficulty gaining enough confidence to do changes. So you don't want your configuration management running your half-baked module to change a VLAN on your core switch because you're not confident that that change is not going to blow up your network and make things worse. The entire point of doing this is to gain certainty and take advantage of the fact that it costs us nothing to do a lot of it, ultimately. You, again, might not be big enough to take advantage of scaling efficiencies. So I worked at BT a long time ago, and we used to build things out by the rack. So you'd get a kickstart, you'd rack a bunch of machines, and you'd kick them, and that would be your Oracle rack cluster. You do a little bit minor configuration stuff to it. But it that was 2006. I imagine things have come a lot further since then, where you're not, maybe even getting them pre-provisioned. Basically, it comes down to you only have to care more about your hardware if you only have a few servers. Once you have enough servers, either somebody else is worrying about the hardware, because you have a dedicated hardware team, or you just have so many, you don't worry about them, they're cattle. And again, some mechanical action is required because somebody has to plug in cables and rack hardware and do all of that, at least for now. I'm sure somebody's working on changing that. So bringing it back to LAN. So pretty much everything we dealt with in the beginning was on the left-hand side of the stack here. And the right-hand side of the stack there's ways to scale out of or virtualize out of the hardware issue. And there's ways to architect around things. Storage is actually increasingly becoming more and more commodity, more application-based. Not at the absolute high end, but I'm not sure how many people here are in the absolute high end. And there's natural scaling points here, as we pointed out before. So, oh man, I lost my place. Anyway, so architecting around things. So we'll focus on the networking hardware because that's the stuff that's difficult and really why I'm talking. Software-defined networking issues. There is some seriously immature network virtualization right now. VMware, I think, recently introduced NSX, which is supposed to be VMware's answer to network virtualization. So you can virtualize and test your networking environments. Unfortunately, it's proprietary. It's VMware only. It's because it's CMC, it's likely to be incredibly expensive once it actually is out of its beta state, and it's pretty new. The secondary problem is the lack of mature cross-vendor management solutions. We have no common language for dealing with networking. We have a sort of common language, but the actual configuration changes, there is no common language. There is no single DSL for it. I am aware of netconf, so I said, well, it's kind of sort of netconf if you squint at it. Because netconf does not is not across all vendors. If you want to look up the RFC for netconf, it's 6241. And this would be an issue even if you manage to achieve a single vendor at your site, because again, we want common languages to do these things because we want to be able to collaborate with other people. So if I'm an entirely Cisco shop and someone else is entirely Juniper, we want to be able to talk in the same way about the same things and reuse code. And the way to do that would be abstraction. And the network device almost certainly doesn't slot into our existing CM scheme. And then to further complicate things, networking equipment is really expensive. So I mean, even cheap switches are several $1,000s. It's not just toss away end-of-the-year budget money on. And they also have long-term delivery dates. So it's not like you at the end of the year, you have $10,000, you just buy a Nexus. And again, networking is not a change once endeavor at present, so you have to continually make changes. So to build on the talk this morning, it's not you build it once and you can forget about it because it's a container and it's disposable. It's a long-going, ongoing concern. You're going to have to go back and make changes, although the frequency of these changes may differ. So again, because apparently I love manufacturing, I go into the whole Six Sigma thing of asking myself a bunch of questions, which is, what do we really care about here? We care about getting enough certainty in our processes to do changes in a reliable way. And what we're really after is reliable service. And what are our changes we're really making, especially when it comes to networking? What is the most common change you make? You down a port, you change a port's VLAN. You're not really generally doing heavy OSPF or BGP backend stuff. It's generally pretty simple stuff for the most frequent changes, which is also where not an awful lot of the complexity is. I mean, if you're just talking about an access distribution switch, changing a VLAN on that switch does not have a high dependency threshold or amount of work you have to do to calculate dependencies on it. And finally, what does it all mean anyway? Because I'm kind of confused now. But that's actually a manufacturing technique where you just keep asking, why are you doing this? 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 To either you don't get an answer you've asked 5 times, to kind of make sure that you're not going off the deep end for no real reason. So what I end up coming up with for networking is we need an agent that is agnostic to config management. So I don't want Puppet directly talking to my network device. I don't like Puppet managing a service that manages my network device, or Chef managing a service that manages my network device. And so my first thought on this was a simple state machine. So at this point, I look around the room, and anyone who gets wide-eyed and like a certain glazed expression was probably a computer science major. And in order to do that, we need some very basic things. So we need to be able to get what the current state is, which is fairly trivial in theory. In order to, we need that because we need to know if we need to change it. And if we need to change it, we need the ability to change it. And then we repoll and did the change work, yes or no? And the ideal way to do this, of course, is with a guest plugin framework. So the best analog I can think of for this is Vagrant. Vagrant is a fantastic model for this type of thing because of its guest plugin framework and how it works. You can basically have Vagrant spin up any VM ever made as long as it accepts SSH and manage things on it via guest plugins. You might have to write the guest plugins, but you're going to have to, sorry. Anyway. So we want a vendor agnostic framework. Now, what that allows you to do is allows you to unit test the actual changes on equipment as you get it. So you can unit test that I can flip a VLAN on a Juniper device or a Cisco device or an Avaya device or pretty much any device by any manufacturer you want, which allows you to concern yourself solely with functional testing as opposed to whether or not your CM solution is working correctly, which is a very important thing. And you can unit test in a lab if you want to. The thing you need to do for functional testing, which again is kind of half-baked, is a Canary Network. So this is just 2 switches and a J-series router. The J-series router is not screwed in, which I wish I'd realized that before I put the picture up, because that makes me look bad. But it is on a shelf, so they don't make these anymore, but the Juniper J-series routers basically have the complete Junos feature set, by and large, with only a couple minor exceptions. So they make really good kind of lab routers, especially when attached to the switches. And then off these, of course, each one of those switches is cabling going into an ASXi host. And the reason why I think a Canary network works is that what I'm really worried about when I'm doing functional testing of a network is that point A can talk to point B in a certain way. That's the change I want to make sure has happened correctly. So I'm testing service flow through those. I'm not necessarily doing performance testing. That's probably more manual lab at this point, just because I don't think I can get decent enough equipment to automate it. And then, of course, if you had that previous machine and you have the Canary Network and you have all that, you do all kinds of other things with it, like provisioning. But there's not really any point in doing that because Vagrant basically does it. And again, I don't really want to extend Vagrant because that didn't go well for me last time. And I imagine Mitchell Hashimoto is eventually going to get around to it because he seems to be being really good about supporting extra virtualization platforms. So in summary, the big challenges to completely managing your infrastructure with software is your information collection, storage, and digestion capabilities. So you need to be very good about getting information from other information. Provisioning automation may be a problem for you. Some specific services may be a problem for you. Puppet in particular is really hard to manage bind with in an intelligent way, particularly a meta way. So if you're defining it statically, it's really easy. If you're not, it's next to impossible. Again, because of the lack of introspection. There's some architectural limitations. A good example is AWS DNS. You don't know what the host names of your machine are until kind of past the point where they made that information is probably useful. And again, DNS, because I already said it twice, so I felt like I should emphasize that DNS can be slightly problematic. And if you're interested in that, and kind of some of the individual topics, particularly CI or CD, last year's UCMS had dedicated talks that were, I think, were an hour and 15 minutes long, or 45 minutes to an hour, Chris? Do you remember? Something like that?
Yeah, I think those 2 were about 45 minutes last year.
Okay, so there are 2 45 minutes talks completely on the 2 topics I covered in the beginning of this, which is Matthew Barr did one on continuously integrating Puppet, and Tim Gerla did continuous deployment with Ansible. And those are both available on YouTube. And then, of course, the talk this morning also went into some of the workflow components. If you're also interested in that, the entire Martin Fowler signature series is very good, but particularly his books on CI and CD. And that about covers us, so I think I also went a little fast.
I'm sorry, it's,
Huh?
It's catching.
my bad, man, it was contagious.
So, anyone have any questions? You know what? Well, we're going to go to lunch really quickly if no one has questions. So. Or break.
So have you seen VXLAN?
No.
Okay, it's crazy. It breaks everything that I know, and I don't really know that much to begin with.
Okay.
But basically, the idea is it's better VLANs, better for some value of better. Where normally with VLANs you tag a port on the switch, and then you have the extra tag in the TCP header and all of this stuff. But VXLAN encapsulates all of your TCP and UDP and adds an extra VXLAN header that has all of the tagging information in there. So you do end-to-end over UDP. It doesn't matter what switches you have behind it. You could have hubs behind all of your servers, and VXLAN would work, and you would have the moral equivalent of VLAN tagging. And it's insane. It's crazy. And obviously, there's a lot of overhead on your servers to make this happen.
Is that all like layer 3 or?
Yeah.
above, or?
Yeah. Well, yes. And because it encapsulates. Yes. Yes. That's what it is. I couldn't remember if it was 2 over 3 or 3 over 2, but yeah. It encapsulates layer 3 in layer 2. It's insane. It's crazy. But it would seem to me, and obviously if you've just heard of it, you maybe can't answer this, but it seems like that could offer a really powerful model for moving forward with software-defined networking and software-defined infrastructure, because at that point, the hardware, as long as there's a cable, like the hardware simply ceases to matter. And obviously, it's unfair for me to ask for your snap judgment on this, but I'm going to ask for your snap judgment on this.
It sounds like a good idea. I'd worry a little bit about how much overhead that actually incurs. Because you can kind of already architect around the networking problem as is, just with proper virtualization architecture or cloud architecture, where you don't have to, you're trunking all the VLANs into single machines, and then the machine is selecting them. So I'd say it sounds like a good idea. I need to learn more about it. The most intriguing thing, I think, is the way Cisco phones do voice VLAN selection. So the machine itself can actually do CDP on the port and detect what the voice VLAN is and switch itself. So it's kind of like a trunk interface that's not a trunk interface, but I don't know quite enough about it to know exactly how they're doing it. It's a weird Cisco proprietary unified communication system thing. Okay. Anything else?
When you were talking about Vagrant as being like some part of the solution, I'm kind of a little bit questioning, or maybe asking the question, if you have any kind of experience with Vagrant on non-Linux systems, as in BSDs or Solaris or IX, because I currently have the impression that like a lot of tools are actually quite a lot of focused on Linux, and I don't know how many of you are actually still like maintaining FreeBSD or NetBSD servers. It used to be more and more topic like in historically seen, but I don't know, like I currently have the focus that everything is very, very Linux centric, if not even saying like Ubuntu or Red Hat centric. So I was as like the question coming back to yeah.
Vagrant itself will manage anything that has SSH.
Right.
So where you're running it, it will run on most things. So I mean, I run it on my laptop all the time, which is basically BSD. To run it for free, you need VirtualBox, which I think is Solaris, BSD. Yeah, I think you should in general be pretty good for Vagrant support.
I mean, like, have you seen it in real world use on
I've run it
and
on
with BSDs?
I've run it on the latest version of FreeBSD. I run it on OS X, and I've run it on Linux.
Okay.
I don't have any Solaris machines kicking around anymore,
Yeah.
or else I would have tried it on Solaris.
Yeah. One more happy customer.
Yeah, well, we managed to kill the last. We had an old Hitachi Sun clone, which was like 20 years old, that was running one of our old web environments that we finally got rid of, and that was our last Solaris machine.
All right.
So,
Thanks a lot.
thank you. Anything else?
Hi. I may be missing something. The connection between the overall talk that you gave and then you had a slide on data deduplication.
Okay.
And I'm just wondering, I mean, I understand that's part of the infrastructure too, but I guess from my perspective, what I'm thinking about are more problems like the technology stack. So can you just talk about how that plays into the overall discussion and what you were saying about the models for that?
Yeah, sure. So basically, every time you're building a server out, or a Canary server, or using a Canary server, it's a very expensive process. So you want to minimize the number of servers you spin up. So in order to do that, you need to duplicate common things. So if you have a pool of Apache servers, so I actually should have gone into more detail on this when I had the LAMP slide up. But the way you scale LAMP is kind of naturally. You cluster MySQL or the underlying database, and then make sure the application architecture is configured to be able to handle a MySQL cluster. And then you kind of duplicate out the application nodes, and you end up with this giant pool of services. But if you had to, at any given point, you could collapse that down to one stack. Now, you wouldn't get the scaling or reliability or load capability. But you would have, in a sense, deduplicated those duplicate services down to the bare minimum needed for testing. And that's more what I meant. I'm not sure if that answered your question or not.
Just my understanding of dedupe is more massive data storage problems. You know, I work in bioinformatics, genetics information, so I just wasn't sure I'd made the context connection there of what you were talking about.
Okay, great.
Thank you.
Welcome. What else? It's right around.
One more here. So you had a slide in there talking about ways to speed up CI and testing only the things that need to be tested, and you had all of these horrible ways to figure out how to do that with Puppet, and without prejudice towards Puppet, because I think that's pretty much the state of the art with a lot of CM systems. This is awful, and why isn't it changing faster, and why aren't we fixing this? Because that's appalling. Like, introspection is just nothing. It's worthless.
Well, I mean, the alternative would be to go off of a single source of truth. The problem comes when you want dynamism. Like, when you want this service to impact this other service, it actually becomes really difficult to do. So if you had a single source of truth like Hira, like all of your data and all of your configuration data and all of your servers and everything in Hira as a single kind of source of truth for it, you wouldn't have to worry about any of this because you'd have ways of crawling the tree to figure it out in much more sane ways. So it might just be that we are chasing dynamism for our own peril. I don't know. I hope there's a better way of doing it. I hope it comes along soon. But right now, it's just a series of horrific kludges that are really cool when you look at the code. But like I have a great highly meta ENC I was building for Puppet on my GitHub, which I think is the coolest thing there, that you should never, ever, ever use. Because it basically defines a DSL dynamically based off a config file. Yeah. I have some
You're
really
a bad
horrible
person.
ideas sometimes, yes.
Actually, I just want to jump into this topic. There used to be a BOF yesterday, which didn't happen because everybody was having a great dinner. But I wanted to talk about like inventory management yesterday evening, and about like how to actually organize your things, which is actually more or less what you're talking about.
Yep.
And my personal opinion is there that almost everything that looks at the way how it is defined is a completely broken approach. So what we do is we actually have a second tool, which I wasn't talking about today, but it's named CIN for C inventory. And the idea there is like to be completely loosely coupled to any configuration management system, and it has like a very small database. The only thing it actually does is is inventory management, plus it allows you to script out using some kind of process framework to every kind of tool you actually like to. So yeah, just to answer your question, the tool is there. It is not very much popular and not very well known, but it exists.
Great. I mean, my main concern with tools like that is I've used some of them in the past, and getting everybody to actually use them. So actually getting the inventory reliable and up to date, especially without support from upstream for those resources to do so, can really compromise those tools. And if they're not accurate, they're almost worse than not.
Yep.
So that's kind of why I've gone more towards trying to automate gathering that information as opposed to, well, I know the servers I ordered, and I know where they are, I can just put all this in a database and, or a tool and use that as a source of truth. Thank you. Anyone else? No? No? Okay.